Most people blame mechanics, loose belts, weak frames, bad rigidity, but often the real limit is electrical. Stepper torque comes from coil current. No current rise, no torque rise. A stepper winding is an RL circuit, so current cannot rise instantly. Its response speed is set by the electrical time constant, tau equals L over R. At high RPM, back EMF pushes against the driver, so current builds even more slowly. Now quantify it. A 1.8 degree stepper has 200 full steps per revolution. At 1000 revolutions per minute, one full step lasts only 0.3 milliseconds. In that tiny window, the driver must switch, fight inductance, fight back EMF, and build current. Microstepping raises command frequency even more. At full step, the command rate is about 3.3 kHz. At 1/16th microstepping, it becomes 53.3 kHz. So the real limit is electrodynamic timing. If current rise time is longer than the available step time, the motor cannot physically deliver that torque. Next, why higher driver voltage helps.